The Lockheed P-38 Lightning looked like something from the future. Twin booms, a central nacelle, counter-rotating props. It was unlike anything the Allies or Axis had seen. But beneath that futuristic design were real structural limitations and flight quirks that nearly grounded its potential, at least in Europe. At high speeds, especially in dives, the P-38 suffered from a dangerous compressibility stall. As it approached the transonic range, around 0.7 Mach, shock waves would form over the wings and tail, causing a sudden nose-down pitch. The elevator became useless. Pilots couldn't pull out. More than a few were lost before Lockheed engineers developed dive recovery flaps in later models like the P-38J. But by then, the aircraft had earned the reputation for being unforgiving at the edge of its flight envelope. Its twin-boom design, while structurally clever, gave the Lightning a slow roll rate. Compared to nimble single-engine fighters, it struggled to respond quickly in turning dogfights, a real disadvantage in close-quarters combat. And then there were the engines. The early Allison V-1710, equipped with turbo superchargers, were finicky at altitude. Poor intercooling in cold European air often led to detonation, while vibrations and heat cycling caused frequent turbo failures. Worst of all, if one engine failed, the plane became a nightmare to control. Wide engine spacing meant severe asymmetric thrust, making a single-engine landing a test of skill and luck. Inside the cockpit, it wasn't much better. Heating was inadequate. At high altitude, pilots often battled frostbite or numb hands. Visibility to the rear was poor due to the canopy framing. And maintenance? Ground crews struggled. The Lightning required far more man-hours than its single-engine cousins, and many field repairs were nearly impossible without factory support. Early in the war, even the tricycle landing gear confused some mechanics. It was that new. So why, despite all this, did the P-38 become the weapon of choice for America's top two aces, Richard Vaughn and Thomas Maguire? It starts with the nose. 4 50 caliber machine guns and a 20mm cannon, all mounted forward, all converging on the same line of fire. Unlike wing-mounted guns that required convergence tuning, the Lightning delivered full firepower at any range. For marksmen like Vaughn and Maguire, that meant deadly, efficient passes, especially in deflection shots. Then there was range. The P-38 carried over 400 gallons of internal fuel, and with drop tanks, it could fly missions over 2,000 miles. That range was unmatched by any U.S. fighter early in the war. It let Vaughn and Maguire strike deep, escorting bombers, ambushing formations, or patrolling vast island chains, all without relying on forward bases. At altitude, the twin-turbo superchargers came into their own. Unlike Europe's freezing skies, the heat in the Pacific reduced many engine issues. The Lightning could hold speed and power above 20,000 feet, crucial for boom and zoom attacks, and with a climb rate around 4,000 feet per minute and strong dive acceleration, it could enter and exit combat on its own terms. Its twin-boom layout, despite affecting roll rate, gave the P-38 an incredibly stable gun platform. Less yaw, less oscillation, and better accuracy, even during high-speed firing runs. And while asymmetric thrust was dangerous, it was also a form of insurance. Unlike single-engine fighters, a Lightning could limp home on one engine. Many pilots, including Maguire, did exactly that. But hardware wasn't the whole story. In Europe, the P-38 struggled, especially in the cold, at high altitudes, against fast German interceptors. But in the Pacific, it thrived. The warmer air reduced icing and engine wear. The open ocean and island geography limited surprise encounters, and most Japanese aircraft were slower, more lightly built, making them perfect targets for the P-38's speed and firepower. Just as importantly, pilots in the Pacific weren't locked into tight escort formations like in Europe. Vaughn and Maguire were given freedom to operate. They flew flexible intercept missions, often alone or in pairs, and developed tactics that matched their aircraft's strengths, not its weaknesses. They trained relentlessly, learned the aircraft's quirks, and adapted faster than their enemies. They didn't fight against the P-38's flaws, they worked around them. with over 70 confirmed kills between them, more than any other US aces in history. So was the P-38 a failure? Only if you judged it by the wrong standards. In Europe's cold, high-altitude environment, it was outclassed. But in the Pacific, where range, firepower, and energy retention mattered most, it was devastating. It wasn't just about the machine, it was about the mission, the environment, and the men who flew it. The P-38 Lightning wasn't perfect, but in the right hands, in the right theater, it became something far greater, a flawed masterpiece that changed the air war in the Pacific. Thank you for watching, and please support my work by purchasing my ebooks. You can find the links in my bio description or by searching for Adrian Langsford on Amazon.